So the human brain is built out of a huge network of neurons. So deep learning is basically an effort in machine learning to create models that mimic the function and structure of the brain. And like any machine learning, other machine learning algorithm, deep learning is trained by exposing the model to many different data examples. So the neural network, while being trained, is exposed into data, and the network has to say what it predicts the data is. So if, for instance, we want to train a model that can recognize a cat, then after each iteration, we'd ask the model, what do you think there is inside this picture, right? And if the model actually gets it wrong, if the deep learning model gets it wrong, then we'd go back and adjust the neural network model until it gets the right answer. And this is going over and over through many different iterations until the model gets everything right. And the amazing thing about deep learning is that while this data is flowing through the neural network model, it's going through a phase of abstraction. The neural network is actually creating this kind of abstraction of the data. So you can look at it as though in the shallow layers, you'd have these blobs of color and edges. And as you move down into the deeper layers, perhaps you'll have pieces of objects and perhaps full object parts. Okay? The amazing thing is that everything emerges automatically. You don't have to specifically tell the deep learning network what to do, what to focus on. Deep learning, by just setting the right setup, the right data, and the right labels, actually knows how to create these features automatically. And I think this is the main factor that have led deep learning to dominate any other machine learning techniques. If you think of classical machine learning, there you'd have to actually have domain expertise. So if you dealt with text or if you dealt with images, then you have to know how to handcraft these features. But deep learning actually gives you an automatic tool that is exposing this feature, creating these features automatically. And I think this single fact have made a very fast adoption of deep learning throughout many different industries, because a software engineer or a text machine learning expert can actually start developing computer vision algorithms because the deep learning model is doing the data representation automatically, right? The other big advantages of deep learning is the fact that it is able to ingest a very big amount of data, perhaps hundreds of millions of data. Example, it has no stop. As much data as you feed it, it will learn and it will improve over time. Okay, there are different types of deep learning. So you can think of different types of deep learning as different modeling of brain structure and function. You have convolutional neural networks, or CNNs, which are basically the neural network passes through the image, applying scanning through the image, applying a convolution operation on the network on the image. By that, creating meaningful features that will allow the network to classify objects, to recognize the scene. You have recurrent neural network, or RNN, which is able to ingest a sequence of examples. So if you're talking about a text, you have a sequence of words. If you're talking about a video, you have a sequence of video frames. So the RNN is able to ingest this information and demonstrate some dynamic behavior. You have a generative adversarial network, which is, you can look at it as two networks competing against each other, which has the ability to generate data which is very similar to the training data set. You can think of application like generating synthetic images and so on. So we have these different types of deep learning. If you're talking about families or how exactly you're training deep learning, you can look at, and it's also true for general machine learning, you can look at several types. One is called supervised learning. So supervised learning is talking about adding a label or the true answer to each example. Okay, so if you train the network to detect objects or vehicles in automotive application, then you have to put a bounding box around the vehicle. You have unsupervised learning, which is very interesting because the idea behind unsupervised learning is that the deep learning model or the learning model will be able to identify meaningful clusters of information. So if you have millions of medical records, then the unsupervised learning method would have to give you some insights about the data, do it in an automatic way, and you have reinforcement learning, which actually allows you through trial and errors improving the deep learning model over time. The amazing thing about all these capabilities of deep learning, which have dominated machine learning for the past decade, is that it takes only a simple set of algorithms and a simple set of mathematical operation in order to achieve these capabilities. If you look at a simple neural network, you're talking about perhaps a single neuron. The only thing this neuron is doing is applying an average sum over its input. The weights of this sum is basically learned in the training process. If you stack several of these neurons with some nonlinearities in between, then you would get a deep neural network, perhaps with some higher capability to represent your data, and by that increasing the accuracy of the neural network. If you look through into a single pass of data for the network, what we call a feed forward, then you can represent almost all the operation in this pass using matrix to matrix multiplication. So I think this is quite an amazing fact, because you would only have, if you are developing a processor for applying or implementing neural network, it will have to have this very strong matrix to matrix multiplication. And that's the main reason why people first turned into GPUs when they trained and when they applied neural networks, even though the initial purpose was video rendering. And today we have dedicated SoC, dedicated hardware that it's meant to optimize this data flow through the hardware, minimize memory access, optimize throughput and compute power in order to be optimized for this specific application of deep learning. People saw that it's highly effective, it's getting them the efficient results. It's best to invest in doing custom hardware, and we're seeing this hardware constantly developing, improving, and we will see that either in the data centers, on the cloud, and also in the end on edge devices. We'll see more and more of this hardware. Yeah.